All right, a couple of proofs here. Firstly, we need to prove that the conjugate of z minus w is equal to the conjugate of z minus the conjugate of w. Okay, so required to prove that the conjugate, so the overall conjugate of z minus w is the same as conjugating z minus the conjugate of w. And to do that, we're going to create a couple of complex numbers. So let's let z equal a plus bi, and we'll let w equal another complex number, c plus di. And we need to say that a, b, c, and d are all real numbers. All right, let's have a look at the left-hand side. So the left-hand side is z minus w all conjugated. So that means I'm going to have the conjugate of a plus bi minus c plus di. All right. And that means I'm conjugating a plus bi minus c minus di. We need to collect all our real and imaginary terms. So we've got a minus c plus b minus di, and we still haven't conjugated it yet. Okay, so now I've collected all my real and my imaginary terms. I haven't conjugated yet. See, I've still got my line above over here. Now what I'm going to do is conjugate. So that means I'm going to change the sign in front of my imaginary components. So the conjugate of z minus w becomes a minus c minus b minus d I. All right, let's have a look at the right-hand side. So this says that the conjugate of z minus the conjugate of w. So that's going to be a plus bi conjugated minus c plus di conjugated. Okay, so let's have a look. I have to conjugate each of those now. So that becomes a minus bi minus c minus di. And that becomes a minus bi minus c plus di. And I can collect them, so it becomes a minus c minus b minus di. And let's see if it's the same. Absolutely, there we go. Therefore, my left-hand side equals my right-hand side. So my conjugate of z minus w is equal to my conjugate of z minus my conjugate of w.